Hi, today we will see how we can programmatically submit LoRa training jobs to Tensorfuse. So the first step is to create a dataset. On the screen, you can see SQL dataset.jsonl file, which contains the dataset in the chat.ml format. So you essentially have a messages array, and then you within the element of each array, you have a role and the content specific to that role. To create this dataset in Tensorfuse, you follow the TensorCube datasets create command. There are two flags. The first is the dataset ID flag. Let me give this dataset an ID video demo. And the second flag is the path to the JSON file. As soon as you press enter, it would start creating a dataset on the S3 bucket, and it would give you back a dataset ID. Let's wait for our dataset to be uploaded to the S3 bucket. So now the dataset is uploaded. We can list all the available datasets using the datasets list command. Yeah, so as you can see, we have a video demo dataset, which was created just 15 seconds ago. We are going to use this dataset to submit our first training job. So let me just reset my terminal. Now, so the first step towards programmatic access is to provide TensorCube with your Hugging Face credentials. I will make use of TensorCube secrets in order to create the Hugging Face credentials. So let me use the TensorCube secret create command. And remember, I am creating the secret in an environment called KDA, which is a specific environment that TensorCube uses in order to train your models. Let me just create the secret. Once the secret is, so the job of this secret is to give Tensorfuse access to your Hugging Face models. Now, the next step to enable programmatic access is to create a user through which you can submit training jobs to your TensorCube environment. So I'll copy this command from here. And let me create a user called video. So this will create an IAM user, and it will give this user permissions to submit training jobs on your behalf. So as you can see, in the end, we get an access key ID and a secret access key. These sort of act as the credentials which will allow programmatic access to submit jobs. So wherever you are planning to call training jobs from, you need to provide these values as environment variables. So let me go ahead and copy these commands from here. And let's see. So I can export the AWS access key ID as follows. And then I can export AWS secret as follows. Okay, now this terminal has the ability to programmatically call my training jobs. So what I can do is I can go ahead and I can write the function to programmatically call the fine-tuning jobs. So let me just copy this code here and paste it here. So you can see there are a bunch of things that can, here are all the things that I can modify for my training run. So I have learning rate, LoRa rank, micro batch size, secrets, epochs, etc. So secrets is where I provide what secret I have created for them to access my Hugging Face model. And in the dataset ID, let me go ahead and give the name of my dataset. So I can list my datasets from here. One second. So if you remember, we created a dataset using datasets list. So this is the dataset that we created, video demo. You can copy the dataset ID directly here, and job name is any name that you want to identify your training runs from. So you can give a particular job name here. So let's say I'm training Llama-70B. So I can give Llama-70 to this job. And job ID is the unique ID that I want to associate every run with. So let me say run number 1. And we are ready. So I can go ahead and I can, one second. So I can go ahead and I can go ahead and directly call python train.py from here, and it would essentially submit a training job for me. It would check whether existing training runs with the same job name and job ID exist or not. And if they don't, it would automatically submit this job on my cluster. So I can go ahead and look at the jobs that are running for my cluster, and I would see the Llama-70 job that I just submitted, and I would see the job ID also. So the job is right now queued, and if I do EKS node viewer, I will start seeing that the job is already deployed on a G6012X instance, which is an instance with 4 L40s. I can also program it. So when we are programmatically submitting jobs, we also want to get the status of the jobs programmatically. So let me create another function. I can go ahead and copy this function, which helps me get the state of the job. Let me just, and let me go ahead and print the status. Also, let me replace my job name with the job that I gave it earlier, and also the job ID with the ID that I gave the job. Okay, now let me go ahead and run status.py, and it would say that my job is already processing. So earlier you saw the status, it was queued, and now since the training run has started, it shows that my job is processing. Okay, and as soon as the job completes, we are ready with the training runs and the LoRa adapters, and we can directly start using them. Thanks a lot for hearing it out. Let me know if you face any, let me know how your experience with programmatic training goes.